feature engineering is another technique for data pre-processing. The features or the attributes, that's the, let's say, it's a simple imagination. We have a column of data. We have a data sets with the columns. Then let's say each of columns are attributes or the features. Let's say that's the simple imagination we can have at the moment. So some information, they contain some information, may or may not useful for the prediction, let's say. Okay, the feature engineering is very important. I actually go to the next slide first and then go back. Okay, why feature engineering is important? Let's say I have 100 features, and we don't normally we don't know how many features are relevant or irrelevant. We never know. But let's say we have 100 features and 98 features aren't related to the prediction. But then, okay, that's fine. But how can we sort it out? We don't want to feed them all to the training model because it's like overheading and it won't give you nice prediction. If you give junk data sets, it will never give you a good prediction. So we want to get rid of them. I just want to feed 2 features. How can we do that? It could have been so perfect if we can test each feature and then decide, oh, actually, it doesn't work for the prediction. Get rid of it. Oh, actually, it works perfect for the prediction. Keep it. It could have been the best, but unfortunately, in most cases, machine learning, we can't do that. So what we have to do is the testing, the combination of features. So that's really hard, like big number. I'm talking about big number. So it's actually NP complete. And we're not happy, but we at least understand why it's important now. So go back. There are broader term about this, the feature engineering. So just going through, feature extraction is extracting the high level feature from data, and transformation is like transform our data to the like Fourier transform. So we know what form is the best before the data, the building a model. And the feature subset selection, that's one thing we just covered over there. So some attributes are more important than the others. So yeah, that's the thing. Also, the feature selection implicitly implicit in our data pre-processing. It's fine. This is a very important topic, by the way, and we can talk for an hour or 2. But for now, I just move on.
Yeah, it's sorry, Nare. Yeah, it's quite interesting. Like, can you go back to the previous slide, please?
Mm-hmm.
So I'll just give you like a real quick example, like feature extraction transformation. So if you got like, let's say your simple problem is the regression problem in n dimension, and you've got like 10 features and you've got like supervised learning. So output is like label data. It could be possible that some of the features that you've got, they are like categorical data, which basically they have like true or false values. So if you see the numerical form of them is 0 or 1. But what you're in regression model, which we are trying to predict is the continuous value. Basically, it's put between 0 to 100, like or whatever. So in that case, you got to decide like how useful would it be to have a feature which is a type of a Boolean values. And if you decide to pick the values which are continuous values, how many of those are like what's a correlation between these features itself? So if I've got 2 features which are pretty much the same, like if one changes, the other one changes in the same direction, then it doesn't make sense to have both of them. I could rather just have one. So this is where they use the covariance metrics to decide which feature varies more from each other, and then we pick what feature would be the best to keep. So I might just like have one feature out of 5 because all 5 values basically changes, like when one changes. And this is what we have to do, because now imagine we have reduced like the complexity of our model from 5 different variables to 1 different variable. So we don't like our n-dimensional plane would be 4 dimensions smaller, which would be easier to train and faster to train. And it couldn't be possible without if we hadn't given enough focus to the feature engineering.
This
That's it.
very good. Thanks, Josh. Really, really, that's important thing we should mention. Really good. Thanks.
You can take over now. Sorry, I keep interrupting you.
No, it's really good. That's the thing with this Saturday study. Like we always discuss. Yeah, Yash made a really good point. If you have the same data, why would you have like a bunch of them? Just have one. Yeah, that's actually means this as well. We want features that can be used for the prediction, not just the chunky ones, right? Or the duplicates. So this title means everything. The feature cannot be considered independently, which means you need both of them. If you need useful features altogether, that's what it implies. So in this example, we have feature 1 and 2. And all right, it looks so easy to divide the classes and predict what's the this one will be like. It's gonna be red, right? But if you just consider the feature 1 only or the feature 2 only, I don't know if it's that easy, because you just lost most important information. So I think it kind of I think you get straightforward. So what I want to say is, don't throw your useful feature away, because that actually contains a lot for the prediction. So always use them together, not separately.